If you think of the blink of your eye, we've just taken 100,000 images in that space of time. You can take something which is a very simple design of telescope, and you can do something which is so fundamentally amazing with it. You start to see the universe in an entirely new light. And so that's something which I find fascinating about this area of astronomy. My name is Michael Daniel. I'm the Operations Manager for VERITAS. VERITAS stands for the Very Energetic Radiation Imaging Telescope Array System. If we think of the electromagnetic spectrum, you start at radio waves, microwaves, infrared, pass that into ultraviolet, X-rays and gamma rays. Photons, we like to dub them the friendly particle. They just love to interact with something. When a gamma ray enters the atmosphere, it immediately interacts and it converts itself into an electron-positron, so a pair of particles. Those particles generate more light, which generates more particles, and so on. So around about 20 kilometers up in the atmosphere, the gamma ray annihilates itself. Particles in the air shower are traveling faster than the speed of light can in the atmosphere. And when that happens, just like a plane traveling faster than the speed of sound, a particle traveling faster than the speed of light, the plane has a sonic boom, the particle has a light boom, it generates Cherenkov light. That's just optical photons which then reach the ground. Cherenkov light is 1/10,000th the amount of light that you get from starlight, scattered light from cities, the general glow of the atmosphere in itself. So you're looking for something which is very, very faint. The reason we can see this is because all of that light is happening all the time, whereas the Cherenkov radiation happens in a very, very short period of space of a few nanoseconds. And so by having a very inexpensive telescope, but with a very, very fast detector, it's only 500 pixels, it's not even that high resolution, we are then actually able to image something which is so outside of our normal expectations. We look at what's called the non-thermal universe. So we look at things which are, so after a star has died, it's gone supernova, all of the energy that was contained within it has been thrown out into the interstellar medium. Those particles collide with interstellar clouds, things bump together and generate the cosmic rays and things like that. So in the 1950s, a couple of smart people decided, okay, we're going to a very dark site, we're going to get some very fast detectors in order to be able to measure this Cherenkov light. They decided we would take our photomultiplier tube, put it in a dark container, in this case it was just a trash can, and pointed it at the sky, and they measured the fast flashes of the Cherenkov light as it came through. The next generation is what's called the Cherenkov telescope array, and that's going to be an array of 3 different telescope types. They will be like VERITAS, but where VERITAS is 4 telescopes, there will be 25 telescopes in the southern array and 15 telescopes in the northern array. And you will be able to collect the gamma rays over a much larger area on the ground. And so by having a northern array and a southern array, we get full sky coverage, we get to see more of these sources, and by having more of these sources, we get to understand the fundamental physics behind them.